In part 1 I showed how I turn these handles for a compound vise, but I still have a number of operations to do, so I'm going to go ahead and get them set up on the mill. This is called a prismatic jaw, and it's designed to hold round parts in a vise, but I find that it comes in handy to use as a V-block for milling small parts. I got this one from Grizzly, and they're going for about $11 now. This is the setup that I'm going to go with. I'm going to mill a flat on this center section here. I could have set this up in a vise, but I decided to go with this setup instead. This clamp is for holding the V-block to the table, so I don't have to realign the V-block whenever I release the part. This is the main clamp holding the part to the table. It wouldn't have done me any good to put the entire part over the V-block because of the reduced diameter on this end section here. So I added this clamp. I don't have it tightened down real tight, just enough to give it some downward pressure on this side and to make sure that the part's not cocked. And as usual with this machine, I'm going to be taking light cuts. Okay, I have my clamps rearranged so I can mill this end. I have to mill in 490 thousandths, so I'm just going to make a mark right here and mill over that mark. And I'm going to mill it 70 thousandths deep, 5 thousandths at a time. I'm going to bring my cutter over to the workpiece and just touch it, zero my dial. While the part's still clamped, I want to drill a pilot hole in this center and drill and tap a hole on the end here. Now, to lay this hole out, I'm going to measure the width of my V-block divide that by 2, set my calipers to that, and I'm going to use another V-block as a guide, and using the inside part of my caliper, I'm going to make a scribe mark. Now to lay out this hole on the end, I'm going to do the same thing, but I'm going to measure the diameter of the part and divide that by 2, set my calipers to that, and bring my guide over and make my mark. And I'm going to scribe middle way of these flats. Hey, while the part's still clamped to the table, I went ahead and made my center punch marks, and I center drilled each hole. I'm going to go ahead and drill this through just till it pokes out the other side, and I can use that hole later on to align the part. Okay, for this end hole, I'm going to bring down my drill bit and just touch the part, lock my spindle, zero my dial, bring my spindle back up a little bit, bring it over the hole, and bring it back down to 0. And I'm going to drill down 75% the thickness of this part. Okay, I had the hole drilled for a 5/16 tap. I'm going to start it with a taper tap and finish it off with a bottoming tap. Okay, I had the part flipped around, and I'm going to mill another flat on this middle section here. Now there's a couple different ways that I could index this to ensure that my flats were parallel. I could run a drill bit down in here and tighten the clamp down, or I could take advantage of this flat right here, and if I had a parallel that fit underneath there, I could use that. Or I had this adjustable parallel that I can fit right up underneath of it, and that'll make sure my alignment is correct. Okay, I have the part moved over, and I'm just going to drill this hole out to 3/8. Well, it looks like there's going to be another part to this. Still have a few things left to do. Have to cut the keyways and the handles and install the set screws. Have to make the handle cranks, and have to turn a shoulder in on these lead screws and cut the keyways in on those. So that's the video. I'll see you in part 3, and thanks for watching.